In this short video series, I will try to summarize Gottlob Frege's main works. Gottlob Frege is originally a mathematician. He wrote his PhD dissertation on imaginary numbers, but with an ambitious philosophical goal, he produced several masterpieces in philosophy of language, philosophy of logic, philosophy of mathematics, and philosophy of mind. The epistemological part of Frege's overall project is called logicism. According to logicism, mathematics, or our beliefs in mathematics, mathematical judgments, is purely logical, not psychological. The metaphysical part of the project is called Platonism, according to which mathematical reality is independent of human mind or the physical universe. Let's start with his first book, Begriffsschrift. The aim of this book is hidden in the title of the book. Begriff means concept. Schrift means script or notation. Begriffsschrift means concept script, concept notation. But in this context, it means a formula language of pure thought. The aim of writing this book is to justify arithmetical judgments logically, to construct a language in which mathematical judgments can be expressed. Mathematical judgments consist of multiple generalities. There is no one subject and predicate as it is in Aristotelian logic. But as it is in this Goldbach conjecture, every even integer greater than 2 can be expressed as a sum of 2 primes. This sentence contains three variables. So we need function argument analysis instead of this old traditional subject predicate analysis. There are several differences between natural languages like English, Turkish, and Begriffsschrift, Frege's artificial language. Natural languages are like an eye, but Begriffsschrift is like a microscope, just as other artificial languages. Natural languages are flexible, but Begriffsschrift is rigid, resolute. There is no place for ambiguity in Begriffsschrift. Natural languages are adaptable for the most diverse circumstances. You can use English or Turkish to write a poem, or you can use it to discuss something political, but Begriffsschrift is devised for a particular scientific purpose. There are 2 kinds of symbols in Begriffsschrift. First one is constants. Constant stands for objects and functions. There are also variables. Variables stand for objects left undetermined and functions left undetermined, like a number left undetermined and a function left undetermined. Frege's Begriffsschrift is in 2-dimensional notation, which means that there are horizontal lines and vertical lines, which we'll see. Horizontal line means the content. It means that the proposition that M, or the thought that M, and M can be a sentence, a proposition. We cannot just write here a word. So it's like the proposition that snow is white, or the proposition that Aristotle is a philosopher. We have also a judgment stroke. Judgment stroke means we assert this proposition. In other words, it is true that the content that, or it is true that the proposition that M, whatever the proposition is. We have conditionality stroke. You know conditionality from your logic courses. In modern notation, we have A implies B, but in Frege's original 2-dimensional notation, antecedent is written here, and we have consequent, content stroke, and judgment stroke. There is also negation stroke. So judgment stroke, content stroke, and negation stroke, content and content of the expression, the proposition. In modern notation, it is simple. There is also identity symbol, identity between 2 proposition, 2 sentence. Identity is discussed in his another paper on sense and reference, which you may remember from your philosophy of language courses. We will not go into this problem. There is also a quantifier in Frege's system. This is universal quantifier, generality. It means that for all A, this German Gothic letter A stands for the variable, and this curve means for all. For all A, this formula holds. This is universal quantifier. So we have negation, conditionality, and universal quantifier. And we have a derivation model. You remember modus ponens, I think, from your logic courses. In Frege's system, suppose we have two premises. A implies B, and second premise is A. A implies B eliminates the possibility that A is true but B is false, right? If A implies B, we cannot say that A is true but B is false. But similarly, this second premise, it means it is true that A eliminates two other possibilities, because in these possibilities A is denied, but here we assert that A is true. So then we are left with this first possibility. A is affirmed and B is affirmed. We already know that A is affirmed, second premise says. So the new information here is that B is affirmed. Conjunction, disjunction, and other operators, connectives in natural languages can be represented in Begriffsschrift system. You can represent A and B in Frege's two-dimensional system. But before, I recommend you to transform them into modern notation with the connectives allowed in Frege's system, right? There is no such AND connective in Frege's system, but we have negation and conditionality, and you know that these two expressions are equivalent, right? So in Frege's system, negation is here. Then we have conditionality. There is conditionality. Antecedent is A. Consequent is not B. So then that's the representation of A and B in Frege's Begriffsschrift. Same for A or B. It's equivalent. And in Frege's system, antecedent not A, consequent B. For quantificational sentences, predicate logic sentences, everything is bold. We can use same strategy. For all x, we have universal quantifier here, then the formula. For something is bold, negation, universal quantifier, negation, and the formula. Negation here, then universal quantifier with variable. Negation, then formula with same variable. Something is not bold, you can try it by yourself. This is Frege notation for it. Nothing is bold. Frege notation again. Every man is bold. Now there are two predicates, right? Man and bold. For all x, man x implies bold x. And in Frege notation again, universal quantifier, then this conditionality sentence, which is in the scope of universal quantifier, we have conditionality here, antecedent and consequent. So same for some men are bold, just try it by yourself. Some men are not bold, here it's equivalent in Frege notation, and no man is bold, right, in Frege notation. Everything is in the place. One other important notion in Frege's Begriffsschrift, we already mentioned this, is function, because Frege's Begriffsschrift is based on function argument analysis of language. Frege rejects subject-predicate analysis of language. Instead, we need function argument analysis. But Frege's approach is liberal. I mean, there is no unique analysis of a sentence. Like, we have two sentences here. Carbon dioxide is heavier than hydrogen, and carbon dioxide is heavier than oxygen. In these sentences, in our analysis, one part will be the constant, the other part is varying. Suppose hydrogen in the first sentence is the argument, and we have the function carbon dioxide is heavier than some argument. In the second sentence, we have same function with different argument. Carbon dioxide is heavier than oxygen. Carbon dioxide is heavier than something is the function. Oxygen is the analysis. But we can analyze same expressions in this way as well. Carbon dioxide here is the argument now. Rest of the sentence is the function. Something is heavier than hydrogen is the function. Or in second sentence, something is heavier than oxygen is the function and carbon dioxide is the argument. In the first analysis, we have same function but different arguments. But in the second analysis, we have same argument but with different functions. This different analysis, right, has nothing to do with the conceptual content of this sentence, this expression. Instead, it is only about our way of grasping these sentences. We can grasp these sentences in two ways, depending on what is function and what is argument. So, function-argument analysis is way better than subject-predicate analysis. In function-argument analysis, with function-argument analysis, we can represent mathematical complexities with a function and n tuple of arguments. That's the end of the Begriffsschrift. Thanks.